Let's go over this warm-up. Okay, so this says using the or the function g of x is defined below, write the end behavior using limit statements. So this is a polynomial. So I heard some people explaining it to each other, which is good. We look at the leading term, which is not necessarily the first one, but it's got the highest exponent. So this is my leading term. That is an odd degree and a negative leading coefficient. Since the leading coefficient is negative, the right-hand side goes down. And since it's an odd degree, the left-hand side is opposite. So that tells you exactly what we need to write. So this is the limit as x approaches negative infinity of g of x. Okay, that's the left-hand side. We are heading towards infinity. Now, overall, for the most part, y'all are doing a really good job with writing these, but some people are still leaving off this. And I don't know if it's happening every time for those people or if it's just sometimes you have a brain fart, because we're all capable of that. But be careful with this because it matters, right? And then we would have the limit as x approaches infinity of g of x, and that goes to negative infinity. All right. Any questions about that? All right, so on this one, it's not multiplied out. Do I need to actually multiply the entire thing out? No, I do not. But I do need to think about what's happening here. I've got x times negative x squared, which is negative x cubed, times x, which is negative x to the fourth, times 2x squared, which is going to be negative 4x to the sixth. Okay? The leading term, leading coefficient matters too. It's negative, so the right-hand side opens down. The exponent is even, so the left-hand side is the same. So that would mean we have the limit as x approaches negative infinity of h of x equals negative infinity, and the limit as x approaches infinity of h of x equals negative infinity. Okay? Any questions about either one of those? What's your question? What's your question? You have a question. Tell me, I look on your face. Okay. Even is the same, yes. All right, we're good? All righty, put those away till next time. And let's get started on this. So this is going on page 88 when we're done. And we're doing sinusoidal function, context, and data modeling, which means we've got some regression stuff going on in here. And it's more your actual application problems, even though not all of these are actually applications. But so we've looked at different methods to construct models. So we are going to create function models for sinusoidal functions, meaning they could be sine or cosine. We've already seen that it can be written like this or something very similar for cosine, okay? Some of what we're going to do today is going to feel very much like what we did yesterday, but that's okay because we can always use some more practice, okay? So let's look at this first one. It says the graph of f, let f be a sinusoidal function. Sorry, maybe I shouldn't just make up words. The graph of y equals f of x is given in the xy plane. What is the period of f? So even though I'm looking for the period, I still think the first thing that is good for you to do is to draw in your, or sketch in your midline, because that can kind of help you with the starting and ending position. You don't have to start at 0, and sometimes it doesn't make sense to start at 0, but if you can start at 0, that really does make things easiest. So I'm going to start here. There's one cycle, and even if this said it was a cosine function, that still is one cycle of something, and the period is going to be the same. Starting at 0, going to here, so my period is 2. And there was some confusion earlier. I was trying to help somebody understand that. So notice, like on this graph, your input values have pi's in them. On this graph, they don't. Whether your input values have pi's in them or not, you still find the period and the b value the same way. Now, they did not ask me for the b value here, but if I needed it to write an equation, remember the b value is always 2 pi divided by the period. The period is 2. So when I divide that out, that gives me pi. So sometimes your b value has pi in it and sometimes it doesn't. Just like your input values sometimes have pi in them and sometimes it doesn't. But no matter where there's a pi or not a pi, you still do 2 pi divided by one of them to get the other. Okay, we okay with that? That happens every time no matter what. You're never going to get the b and the period are never going to be the same thing. Okay, we good with that? Any questions? All right, good deal. Okay, let's look at this next one then. It says let g be a sinusoidal function, and then it gave me this equation. Here's the graph of g of x. Which of the following values could represent the constant c? Because remember, there's actually an infinite amount of answers, but we only have 4 choices. So my midline, I know exactly where it is. Don't have to figure it out. It's at -1, even though I could have easily figured it out. And I know that this is a cosine function because it tells me my parent function for cosine looks like this. Okay, so that is cosine theta. And this would be negative cosine theta. And I've said this a few times, but I haven't written it. I think it's confusing some people. Y'all know, and I know you just don't always make the connections, that if you have a negative out in front of a function, it's the reciprocal of it. Just like with a parabola, x squared opens up, negative x squared opens down. So you've known that forever. So it's really the same thing. So cosine starts up here above the midline. Unless it's negative, then it starts down here. Okay, and so just having that in your brain or even writing it down. Now, this is a positive cosine, which tells me I'm starting up above. And this right here is 0, 0 for the parent function. But what is the x-axis here is actually the midline. So it would start, so cosine actually starts above the midline. We'd start here, which is, I guess, technically at 0, 0. Okay, and so clearly, since it's not a reflection, because it's not negative, I have to move left or right. You agree with that? Okay, so it can't be A, because A says we don't go anywhere. Then remember that the x plus c is what we have in there, and this says c. That's a positive pi fourths. That means that this is x plus pi fourths. This is x plus pi halves. And this would be x plus pi. Now, the way that works does not change. X is still a liar, which means since what we see when it's in there is x plus pi, we are actually going to the left. All 3 of these represent a shift to the left. Okay? Everybody good with that? Because I don't want you getting all that confused because I made a big deal about C, because it is a big deal, but not everything changes. Okay? Still have the same rules. So if I start here, this says I would go to the left pi fourths. I would end up right there. That's not on my graph, so I don't like that one. Plus pi halves means I go to the left. Well, and honestly, I could go to the left pi halves or I could go to the right. It really could be either one of them. But when I go to left pi halves, not only am I on my graph, but then it makes the little cosine curve that I would expect. So I really like C, but we're going to check D. So I'm here, and I move to the left pi. That puts me right here. Now, if there was a reflection, then that would work, but there's not a reflection, so I don't like that one. Makes my answer C. Okay? You see how to step your way through it and think through it? The same things my brain does for this. Okay? Any questions at all? Oh, you're right. It looks the same. And to be honest with you, it could be either one. I know because, okay, the reason I know that this is plus is because this says x plus c, and this says the constant c. So if I'm just going to take c and substitute it in there, this is what it looks like. Even though I could, if my answer choice was E and I had a negative pi halves, then I would have 2 correct choices. There can't be more than one right answer. Because if this keeps going and I'm up here, I could have moved to the left pi halves, to the right pi halves, or to the right 3 pi halves. Like I could do a whole lot of things and it would look the same. Does that answer your question? Is that what you're asking? Good question. Anything else? All right, good job. All right, so we got another clock question, but it is a different clock question this time. A clock is mounted on the wall, and the point P is located at the tip of the minute hand of the clock. okay, but I don't know where the minute hand is yet. Says the function h represents the height of point P from the ground at time t, and then this is going to be a sine function. Then h of 0 is 70, h of 30 is 52. And it goes on to say those represent a maximum value and a minimum value respectively on the graph of h. Okay, so here's the minute hand of the clock. This is 0, 70. That's a maximum. Minimum is 30, 52. And I don't know units here, inches, feet, yards, miles, I don't know. But I could tell you that the length of the minute hand would be 15 whatever, right? Yeah, it doesn't say what the height is, so but it's 15. But I don't even really need to know that. Okay, so even though I know that this is sine, if I'm just trying to find, I'm trying to find the values of A and D. So it's my amplitude and my midline. Whether it's sine or cosine, the amplitude and the midline are going to be the same. What would change would be my shift left or right, right? Because they're just shifts of each other. So even though I have that, I mean, I could draw a sine function. It doesn't really matter. But I can't just draw this because I've got a maximum and a minimum. My maximum is here at 0, 70. And my minimum is here at 30, 52. Okay. The total distance from my maximum to my minimum, if I want that, would I be looking at my input values or my output values? Output, because that's vertical, right? And since they're both positive, I can just subtract. What's 70 minus 52? 18, okay? And 18 isn't anything that I need. But if I take half of 18, I can get 9. What would that 9 represent? Amplitude, good. So my midline is in here somewhere, right? But this is my amplitude. So the two amplitudes together give me 18, right? So that's 9 and that's 9, okay? So my amplitude is 9. Everybody okay with that? Now do I have enough information to figure out my midline? Yes. What would I do? Good. I can either subtract 9 from 70 or add it to 52. Either way. 52 plus 9 or 70 minus 9, doesn't matter either way. Midline, which I don't really, like I'm not putting y equals because I don't want actually the midline, I want to know where it is. And that is going to be 61. Okay. It's not impossible, but very difficult to do if you don't draw anything. Okay, I'm drawing this stuff for myself too. I'm not doing it for y'all's benefit to say this might help you. Like if I don't draw this, I'm not going to get all that stuff right in my head. Okay, we good with that? Any questions? Okay. And you're also not going to be able to do it if you don't practice it. Okay, flip it over. Unless you had a question. Were we good? I'm going to give y'all a minute to read this. Not necessarily enough time to solve it. But read it, decide what's important, label some stuff, get yourself started, and then I want to talk you through it. Okay. Okay, gotta give you enough time to get some things labeled. Let's talk through this together. So a yo-yo that's attached to a 30-inch long string is rotated at a constant rate. The figure provides a representation of the yo-yo in the XY plane with the direction of rotation indicated. Okay, so there's little arrows right there. At time t equals 0 seconds, the yo-yo begins to rotate. The yo-yo is at the start position in the figure. So right here, the input is 0 and the output is negative 30. I mean, it's on a grid, so that's kind of obvious to me there. At time t equals 5 seconds, the yo-yo has completed 20 rotations and the yo-yo is in the same position. So that means this is 5, negative 30. Okay, we agree with that? This is back where it started. A sinusoidal function is used to model the x-coordinate of the position of the yo-yo as a function of time in t seconds. Which of the following function is an appropriate model for the situation? Okay, so when I look at my answer choices, all 4 of them are sine. All 4 of them have the same amplitude. The only difference is the b value, okay? And the b value is tied to what part of the graph? What do I have to know to figure out b? The period, okay? So I want to remind you that, okay, so remember this thing, okay? We've talked about it a few times. We're not having to fill all this stuff out in this question, but I showed you another way to do this where we set up a little fraction, then we multiplied it by 1/4, right? And I told you, all right, so if we're going to go from here to here, I've got 5 points, and it gets divided into 4 sections. So that's why we take the fraction we would get, multiply it by 1/4, right? Well, if you think about what because I don't think I made this point when we did it. When we think about the little fraction we get, that means it's going from here to here. That is the period, right? So we don't need to multiply the period times 1/4 because it's a different kind of question, but getting from the word problems, making that fraction gets you the period. And what's weird about the fraction, well, not really weird, but different for you, is that usually when we set up a fraction that has time in it, the time is in the denominator, miles per hour, centimeters per minute, whatever. But when we do it here, we're putting the time in the numerator. So at 5 seconds, we're in the same spot. Did it take 5 seconds for it to go around once? No, that'd be a weird yo-yo, right? But in 5 seconds, we have completed 20 rotations. So we're going to set up a little fraction and say we got 5 seconds, time on top, to complete 20 rotations. I would put the little labels so you make sure you put the right numbers in the right spot. Then we reduce that if we can, and we get 1/4. That is the period. When you set up your little fraction, that is 1 period. Regardless of whether it's sine or cosine, it does not matter. So then, to find b, because that's the only thing that's changed over here, b is going to be, every time, 2 pi divided by 1/4. Okay? Now, before you even do the math, do you think your final answer is going to have a pi in it or not? Yeah. So what can we eliminate? A and b. And then hopefully you can actually do the math right. And what do we get? 8 pi. And the answer is D. Okay. What questions do you have? Are we good? Yes? All right. Okay, so now we have the average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by this function. Based on the model, which of the following is true? So it's asking me about the maximums, the minimums, what they are, and where they are. So I'm going to start, and I'm going to keep adding to this. I'm going to draw, this is sine, so I'm just going to draw one little cycle of sine. Okay? And this is going to be like that other picture I just showed you where there's an x and y axis somewhere, I don't know where, and I don't really care. Okay? Not at this point anyway. Then for just like I've done for everything else, the first important part to me is the midline. The midline is right here. It is what was the x-axis for the parent function. And I know that that midline has a y value of 61.2. Okay. We all agree with that? Okay. So the first answer choice says the maximum average monthly temperature is 61.2 degrees Fahrenheit. What do you think about that answer choice? No. If the midline is 61.2, the maximum clearly is not, right? No matter how bad your picture is, I think you could probably figure it out from there. Like your pictures don't have to be beautiful, but you got to be able to make something out of them. So the next answer choice asks me about when something occurs. So I kind of need some x values up there. So I don't really care exactly where it is. I'm just going to draw a line down here so we can kind of label it as the x-axis. So I'm pretty confident that it's under 61.2. And I want to know for this point right here, what that x value would be. Can anybody tell me what that x value would be? It's not 61.2. 4? Yeah. So if I have, my parent function looks like this, and sign starts at 0, 0, unless I do what? Translate it, right? Are we translating it? Yes. How much? 4. I'm translating it to the right 4, right? That's what affects the x value. So this whole thing gets moved over to the right 4. Okay, I've got that from my equation. I would also like to know where that first cycle ends. What would I need to know to be able to figure that out? The period, okay? And so the period would come from, I'm going to use pi 6. The period is 2 pi divided by pi 6. What's that? 2 pi times 6 over pi, it is 12. Okay. So is this number 12? No. What is it? 16. Because I go from 4 to 16, that is 12 units. Everybody with me? And then everything is symmetric, so it's half, half, half. So that's 16. Right here, what's halfway between 4 and 16? It would be 10. 4 plus 16 is 20, and then we divide by 2, it is 10. Okay. Then here be a maximum and a minimum. What's halfway between 4 and 10? 7. And halfway between 10 and 16? 13. Yay. But unfortunately, B says the average monthly temperature occurs at 1 month. Well, I don't even have a 1 on this graph, right? But if I back up a little bit, make another little curvy curve here, and I can tell between what's on the midline and my maximum and minimum, I'm counting by 3s, right? So if I count backwards by 3, then this happens here at 1. But it wouldn't be a maximum, it would be a minimum, right? This says maximum. I really want the minimum. I don't like B. Yes, if you look at D, minimum average monthly temperature is at 7. That's a maximum, so I don't like D either. So we're hoping it's C, but we should always check because, again, have you ever marked out all 4 of them? I know I have, and then I go back, oh, better go look at something. This says the minimum average monthly temperature is at 35.5. Does that seem reasonable? Does seem reasonable. How could I know for sure that that's it? Okay, this right here, this is my amplitude, right? This is 25.7, this is 25.7. So if I take 61.2 and subtract 25.7, I should get 35.5. Or if you like to add fractions more than you like to subtract them, you think it's at 35.5, you could add the 25.7 and see if you get 61.2. It doesn't matter either way, but you do get 61.2, whether you add or subtract. So my answer is C. That's right. Okay, everybody good with all that? Any questions at all? Okay, that's a lot of drawing. But did you notice I didn't just read it and then go up there and just draw the whole thing? Sometimes you don't need the whole thing, right? So I just drew a piece at a time just to see what I needed. And if I still don't have a y-axis on there, my x-axis probably isn't that accurate, but it doesn't matter. It got me what I needed, okay? Any questions at this point? Awesome. All right. So this last one actually is a regression question, but I'm not going to have you get your calculators out, and I'm not even going to do the whole thing on the calculator, but I'm going to show you some things. So this says the function n gives the number of nighttime hours on the first day of a given month, where t is between 1 and 12. The table gives values of n at selected values of t. This sinusoidal regression with 16 iterations is used to model these data. What is the maximum number of nighttime hours predicted by the sinusoidal function model? Okay, these numbers, not what is predicted by the sinusoidal function model. This is our real data. Our regression is our prediction. Okay, it's important that we remember that. And so when I look at my outputs here, I'm at 11 something, I go down to about 5, and then I come back up to 11. Well, there's a lot of things that we've done where we look at those and go, oh, well, if it goes down and comes back up, it's probably quadratic, right? But that's when we had a choice of quadratic. Knowing nothing else, we could see if how our average rates of change go, and maybe this could be modeled as a quadratic, who knows? But it clearly tells me it's sinusoidal, so that's kind of irrelevant anyway. And I have 4 answer choices. I'm pretty confident my answer is not 5 or 8 because these numbers are a lot bigger than that. But again, this isn't where I'm getting my answers from. What I do know from this for the real data, I'm starting at 11 something, I go down, I don't know exactly where my minimum is. It should be around 5-ish, but it could be 4.5 for all I know, because they don't give me, everything I need there necessarily. And again, that 11.4 and 3, that might not be the highest. It might have gone up, who knows what's going on, right? So I do need to actually look at my prediction. Again, pretty confident it's not these two, because then that would be way far off from my data I'm using. And I just didn't think it was worth y'all getting your computers out where I know you can push buttons. Let me just show you some stuff here. So I typed in the data that's right in front of you. I know you're capable of that. I'm going to zoom in. There are my points. I'm going to hit regression. You've already done that a ton, right? Linear is your default. Clearly, it's not it. When I click on that, I've got all these choices, and then your last one is sinusoidal. Same words that are used in the question. Pretty sure you can find that all on your own. And there's your regression equation for that, okay? Now, this little equation that I know is really hard to see if you're not right here, probably even the front table, it's hard to see, but it doesn't matter. It's a whole bunch of decimals, and it's in the form that they give you right here. But here's what I want you to notice about this. Look at the difference between this and this one that's right above it. Besides the fact that that one actually has information in it, do you see how here B is factored out and here it is not? Okay, so the C's are different, meaning when it's factored out like that, that's how we get to use the transformations we understand, where we know we're just moving to the right for. Here, if I needed to know how much I'm moving to the right or left, I would have to factor B out. Now, I have not seen any sinusoidal regressions where they expect you to do that. I just want to point out the difference here, because, I mean, you do have to do that sometimes in other things, but it's just like a tiny bit different than what you're used to seeing. Plus, kind of like with log, you only get natural log. You're not going to get log log. Here, you're getting sine. You're never going to get cosine. So even if we could write it as a cosine function, which we could, it's always going to be in a sine function. But I can get information from this if I need it, okay? And I don't know if exporting it's going to do any better for y'all to be able to see anything, but I have y equals 3.1175 times sine. So that tells me my amplitude is 3.1 something, right? I mean, you can still get all the same other information out of here. Also, I know y'all are pretty well versed with Desmos, but when I'm trying to figure things out here, I have this black line there, and then I have, why is it blue? Oh, it's because I exported it. I'm going to take that back off. So it's blue like this. But then I have green points up there, and that's these that I put in. I don't want to accidentally choose those because they're really close, so I can turn them off. And then I have my blue curve, okay, and that's what my actual regression is. So then I can just come over here and find my my maximums, and I can export them even. Remember we talked yesterday about the fact that there's an infinite amount of maximums and minimums here. The maximums all have the same output value, otherwise they wouldn't all be the same, but an infinite number of input values. So here's my actual answer, which is 11.333, not even 11.4 like this is. I still don't love this question because you still have to decide between these two, but I would go with 11.3 is a lot closer to 11 than 12. If it was a real question on the real thing, I think it wouldn't be so vague, but still just a good question to talk about, okay? Questions about that? All right, I'm going to give you two things. So I need you to listen. I'm going to give you your assignment. Let's talk about the assignment real quick before I put it in your hands. The very back page looks like FRQ3, non-calculator. The back of the back page, or the other side, the front of the back page, I guess, there's two questions that look like the one we just did. These two are the only two calculator questions on the whole thing. Now, I don't think it's a terrible idea for you necessarily to use the calculator for other things. Like if you're just trying to look at it and wrap your mind around it, just know that you wouldn't have the calculator to actually solve them. You with me on that? But there's nothing wrong with discovering things. But I'm also going to give you a review to the AP unit style test, AP style test rather, that we're going to take on Friday. I just want you to go ahead and have the review, and you've got quizzes on the next 2 days. Okay. No, I took off 3.1 just because it kind of just got melded into everything else. And so quizzing by itself, even testing by itself, I just decided it wasn't important. Because it's not tested like by itself on the AP exam. It's just kind of an introduction into the whole concept. So.